Hi, everyone. Um, Sorry for the late start, but welcome to another episode of the Common Lisp Study Group. I'm your host, Ron Vaden with Atlanta Functional Programming. Today, we're going to just tie up and finish our exploration of the cl-transducers library, a library that I've been covering the last couple of weeks, with the exception of last week, of course, that deals with implementing the closure approach to transducers, which are a way of composing algorithmic transformations in a functional manner inside a common Lisp using the transducers concept that was introduced in closure properly. And please, for folks coming in from other libraries, obviously, please go back to my previous episodes for more information about this library. I thought I would start the discussion with a couple of questions. Well, one question in particular that came directly from the author of the library, actually, who is I was very happy to see that he watched the entire video. I'm glad that I covered it at least to his liking. So thank you, Foskers, for actually watching the Common List Study Group. At some point, you should come join us in your time and show what other cool stuff you're doing in Common Lisp too as well, outside of just CL transducers, of course. Um, in particular, there was one comment that he was making regarding local nicknames for packages that I thought I would start with that discussion today. Additionally, there was a couple of questions he was talking about related to just the fact that he was surprised when compared with series, uh, there was a significant difference in how much CL transducers was consing compared to uh, series itself. Now, part of this is related to, for folks who have been following along and have uh, seen our series on series, no pun intended, um, the design of series is basically based off of the idea that we have a representation of a computation and we actually go through and determine using static analysis actually, assuming all the types align and everything, that the differences between what series calls an online computation and offline computation. And this is in an effort to actually compile the series expression into a much more optimized version of either Lisp or in some cases maybe straight up compiling it straight to a compiled function. Now, the important thing to note is for folks coming from that approach is you have to write your series expressions and make sure that they end up using the phrase optimizable series expression to inside the code to actually go and implement your transformations so that series can use its analytical tools to actually go and do optimizations. CL transducers, on the other hand, at least from my understanding, doesn't necessarily do a lot of that. Of course, I haven't actually had a chance to do a deep dive into its code, and I thought, what would be interesting is given the um, Fosker's comment about the surprise about it consing a lot, even for the simple cases, it might be useful for us to do a deep dive into the actual code and see what's going on. One final thing that we're going to be covering is a kind of the at the end of last 2 weeks ago when we were talking about CL transducers and comparing it with series itself. Um, I gave this sort of like example about summing numbers inside CL transducers. I tried to adopt it with series itself, and I gave a library an approach that looks something like this, where we end up trying to do a native series using the step function with an initial value and a step function of incrementing and grabbing the first 1000 odd integers from this infinite series of integers that we've created. Uh, the one thing that we had before in this was is, well, how do we actually go grab the subseries? And as it turned out, the once we created the infinite series um, of odd integers like we had here, creating subseries, I forgot, and someone reminded me that series has this thing called subseries that allows you to grab and take slices of a particular series based on indexing. And so you give a starting index and an ending index, and well, it's actually a starting index and the size of the subseries that you want, and it'll actually go through and compute that for you at real time. So what we had before, just to write from scratch, was this. We just took this integer here. What we had before was just this, and this obviously when you compute will keep on computing infinite series. I won't compile this right now in my Lisp image because if this will run forever and then it'll eventually slow down the image in terms of computing other stuff. But when you actually use subseries, it'll actually go and just collect enough of the series, and the series library will actually compile it so that we'll actually get the first 1,000 odd integers, and then we could just call collect sum. So we now have essentially three different ways in series to actually compute this sort of transducers examples. And in all three cases, compared to the transducers example, if you recall, if we just go in and um, compile this guy with a time, it will give you, actually, is this the one that was with add? 1 second. Oh, 0 bytes. That's actually surprising. Okay, 1 second. I may need to restart my Lisp because previously this did not work as I expected it to. Let me load CL. Okay. Huh. Maybe that was just a fluke before. So it looks like series for and the transducers implementation both, whereas in our previous episode it says that they were consing a lot. I didn't get any consing here. It says that 0 bytes were cons. So it looks like it might have been the result of me running a infinite. I may have accidentally ran like transducers int 0 in my Lisp image, and because it was consing and it didn't have enough memory, it ended up consing more for these computations. This is one thing about these libraries that we have to be careful about, which is especially when you're dealing with things that are going to compute infinite sequence on demand, you must take extreme care with writing up your computation to make sure that although that you could compute infinitely, it's going to still be running in the background when you keep uh, asking Lisp to do stuff sometimes. So it will slow down your image, and it could end up doing these kinds of situations where your timing mechanisms are going to give you incorrect measurements. So take some extreme caution when you're using these infinite um, sequence functions in general, and if you're writing your own. Uh, so so Foskers, if you're watching this, it looks like this might have been just a case of running something in the background that was consing too much and it messed up my calculations. So let's run these now and do a proper performance analysis of this just to see one more time what the differences is. So we now have again four different one transducer's way of computing the sum of the first 1,000 integers, and then we have three different ways of doing it with series, all of which are very similar in each case. The first one, we're actually just using scan range directly to compute the series, the first thousand odd series for us. Um, Actually, sorry, this is actually not doing the first thousand. Oh yeah, it's computing the first thousand odd integers for us directly by computing it starting from one. And then the next two is us starting with the set of all integers, and then we're using the filter mechanism chooseif to actually go and grab the odds, and then subsequently restricting that to only the first thousand odds. So this is equivalent. The last two are almost identical to the take that you see here. The first one we're computing on demand. In all four cases, it looks like, um, other than maybe computation cycles, like compute cycles. So as you see in the first one, we took about it, even though it took 100% CPU in both cases, nothing was cons. We are it is taking slightly longer with regards to um, computing with transducers versus series. And if we run sub-series on this, let's see this, that's a little more expensive than just computing on demand with scan range. Um, and again, if we instead of computing on demand with scan range, we are computing a little bit more in terms of these. So these are a bit more expensive than just computing completely upfront all the thousand integers like we do here. But they're still faster than um, cl-transducers in terms of processor cycles. Now, this is not a big deal, okay? I'll be honest with you. It it If it wastes a few cycles here and there, it's okay. It's when we start having to do a lot more I/O then that it's going to be a performance problem, okay? Um, this is pretty minuscule, I would think, but it is in terms, it can become expensive over time if you have more of these kinds of like calculations inside of your program. So when you're doing these kinds of analysis, look at the problem that you're actually trying to solve, and then obviously take that into account when determining whether or not transducers would be um, decent for you versus, say, series. Uh, so let's start with some of the questions that Fosker's brought up regarding use of local nicknames. So I'm going to first give the example that was inside his documentation to kind of put this into context. So let me pull that example up. Give me just one second here. And it was right. So we're going to create an example with, say, and I'm going to create a new file for this instead of doing it here. Let me just go ahead and generate that. Lisp projects. Oh, right. Let me go to, one second. Where is that located? Okay, I'll just go ahead and do this in here and then move it around. Um, I'm just going to call this guy series examples. Actually, let me do transducer. Transducers examples. Okay, here we're going to just go ahead and create a package called, let's say, transducers examples. Okay, transducer examples. And sorry for folks who are watching, this always happens. I haven't been able to fix this issue with Doom, and I think this is actually a problem with the the autocomplete that it has, the IntelliSense that it's using. But let's see, we do cl, and what we do is we do in. So what are local nicknames? First off, local nicknames is like think in Python, uh, you are able to do like an import as, so you can have an alias to a particular package. So local nicknames in a package will give us the ability to do the following, and we can actually go and load. And let me first make this a more complete example. Um, Obviously, we want to be able to make this isolated transducers. Even though I have it loaded in my image right now, I'm just making this complete here. Um, oh, sorry. Okay. And what we'll do is, as you notice up until now, we're using transducers. So now I could just say transducers direct T instead of transducers when I'm prefixing all of the exported symbols, and it does kind of the same idea. Okay. So this is what Foskers was suggesting as a best practice to actually use the library. Instead of using transducers over the place, you could use local nicknames to actually go and handle it. The thing that I wasn't sure about, and this is why I thought it would be the first topic of discussion that we should try, is whether or not this would actually work with all Lisps. Because if I recall, at some point, local nicknames was only supported in SBCL. So any of you using Steelbank Common Lisp out there, you can use local nicknames with transducers. You should be good. Okay, as you saw right now, I'm able to actually run. I ran uh, the package, and I was able to actually inside this package now. If I do transducers examples here and do an MRS, sorry. Now, if I run, say, T colon, you could see now all of the exported symbols in the transducers library being available to you. Okay, so that's what local nicknames does. But let's see if we actually switch over to different Lisp, okay, like CCL, whether or not that would actually still apply. In order for me to do this, I have to um, start another Lisp. Let's see, not restart Lisp. Where is that? Start another Lisp. Okay, I'm gonna have to do this. Marbly Sly. Start a new one. No, no, no. That is okay. Give me just 1 second. I have to remind myself in uh, so in there's a way I have all the aliases in my for all the different ones that I use in my my Doom Emacs configuration. Give me a sec, 1 second here. Um, Compile, ask, find, go to, expand. No, this is not going to grab it for me. Uh, let's see. H, R. No, 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 no. Hold on 1 second. There's a quick Sylvester. There's a Emacs command that I could use. I have to just remind myself. Sylvester. Okay, there was go. If I do meta dash, that's not what I wanted. Hold on one second. Meta dash. Okay, hold on. No. One second. Meta dash, meta x, slide. There we go. Okay. At least that's telling me that it's not able to do. Let me see if I try. Let me try clasp. Failed slink. Interesting. Okay. And in that case, give me just one second. Let me open up eShell instead of wasting time. And let's do let's see. Do I have transducer examples? Yes, I do. Okay, so let's do ROS dash Q dash L clasp bin run. What? ROS list install. Oh, so I haven't actually installed those. Let's put after cleaning up my merge system. One second, just need to go and install. Let's do both of these just for completeness sake, and then I'll deal with DCL later on. In the meantime, let me see if I could do this while that's running. Okay, CCL, go. There we go. It's going to take a second to load. Okay, so we now have CCL loaded. Let us come to load that up. Okay, so one second. cl-transducers not found. What? Okay, number 9. Let's do this. Quick load. cl-transducers. Oh, my apologies. It's because did I start this with let me see. Transducers. Oh, right. I'm using the wrong package because in Quick Lisp, cl-transducers is actually named transducers. D3 det. There we go. Now we go. Okay, so it's loading. One thing you may notice is that for each new Lisp that you build, if you're loading something into that Lisp image, for folks especially starting to get comfortable with working with different Lisps, if you've never compiled and loaded that library the first time, it will compile and compile its dependencies before loading it. So that's why you see the list of packages. Whereas before you may have noticed in SBCL, because I've already compiled it in a previous Lisp session, it just loaded those facils because nothing has changed from the last time I actually downloaded it. Okay, so let's go ahead and run this. If I am correct, this will actually fail. Um, oh, really? They added local nicknames. Okay, so this is new because I haven't seen local nicknames work in CCL. Let me try clasp then. Let me do one more test here. And if that works, from now on, I'm using local nicknames. 1 second. Um, okay, this is going to get a little crowded, but bear with me. I'm going to first quit this Lisp, uh, and then I'm going to load um, here, and then do clasp. Oh, okay. 1 second. I just loaded it. Maybe I have to do a ROS, an initial run. Clasp bin run. Okay, I can't run clasp because it looks like my version of LLVM is outdated. Okay, mental note that I have to go and deal with that. All right. Um, Scratch my previous comments. You could use local nicknames, it looks like, at least with CCL. With CLASP and ECL, the jury's still out. I have to go and double check to make sure that I can use them in those versions. And if that is the case, then from now on, local nicknames is actually very useful because it allows you to create quick aliases to packages inside your whenever you're using packages in general. So I'm glad that this is a pleasant surprise for me that this actually works. Um, so thank you, Fosters, for at least mentioning this to me. This at least makes me a little happy. Uh, so that's the first thing. The consing we've already addressed as well. And I just showed you some of the series stuff. What was the other thing that I also wanted to talk about related to this? Yeah. So for those coming from series, um, you may recall, and I'm going to go ahead and put this here for quick stuff. So I know I'm comparing a lot on transducers with series, and it being a new library, this might be kind of a wish list. So Foskers, if you're listening, this is kind of my wish list, at least preferably, and I will certainly get myself involved if in any way I can to actually help this kind of come to fruition. But first, let me first load series to get. Um, okay, so compiled and loaded. This is compiled and loaded. Okay, let's load this guy. Okay, and okay, and transducers examples. Okay, so with series, and let me go ahead and add because I do like writing. I'm gonna go ahead and do S for our series too as well. So this way we don't have any problems as well. And let me reload this and do MRS to do. Okay. With series, you may recall that we have scanners. We have different types of scanners for different types of use cases. Whether or not you're using association list, as you saw with us here with a list, we did a scan function. If you want to write your own custom scan function for scanning, maybe a new IO device that doesn't exist inside the series library available to you. And we have two different types of scanners here. One that where it does a half open interval, and this is a closed interval for including the actual um, ending of the terminate or the terminating conditions last value before it actually exits the scanner. Scans for hash tables, lists of lists, and so forth. The one thing that I thought would be particularly interesting to see is scan stream. And the reason why scan stream is particularly useful is scan stream, at least for series, is something that you could use to read like a socket. Okay. So far, from what I can tell, at least in transducers, there's nothing inside the comparisons functions that would prevent us from actually writing um, a transducers version of the stream. The difference is um, the obviously is the behavior for at least transducers might require us to do some adjustments. Now, if you recall, we had an example for this, and this is why I didn't think I could probably write, spend some time in this discussion to do some exploration of this. But my idea is something similar to what we saw previously with where is it? It was with consing. Let me just pulled up. Where is it? It was, yeah, this one, where we're going through an associative list, and there's this explicit transducers colon cons function that obviously was a wrap around CL cons. As you can see that in the CL cons, we're actually having to make a difference inside of the computation when we're calling the map function versus calling transducers computation. And this is important. This is important, at least as I understand it, for even streams, because with streams you're grabbing a packet and you're sending it across the transducers pipeline. And I'm thinking something similar might need to be changed, but I don't know yet. This is kind of based on my understanding of how this kind of library works. So this is something that I'm digging into right now, and I thought it might be you know, a good exploration to do on the stream. So if folks are, curious on how to hook this up to, say, another library like usocket, where you might be doing some sort of network based sliding window type of data analysis using transducers, you could certainly do so, because this is kind of some of the stuff that you would use to develop, say, something like if you wanted to go through the exercise and develop, say, something like datomic inside Common Lisp, without something where you're able to actually read through um, a socket, at least in a streamlined fashion, hook it up and construct it into a transducers like data structure that can be used in a composable matter through these transformations. Your code's going to get ugly, and you have to write some code to actually make sure that you map it into this transducers world and then unmarshal it to whatever world you need to actually communicate to the external ideas. Does the idea kind of make sense to folks who are listening?
Yeah.
Okay. Um, for so again, this is going to be because my knowledge on transducers is still coming up to speed, so to speak. So I have to look at how transducers kind of does its things with cons to see what we can do in a similar fashion with streams. Um, if there are other questions while I'm going through this kind of coding exercise, feel free to ask. Um, this is obviously an open discussion. This is not just me, just doing kind of like demos and stuff like that. So, um, and uh, so obviously, if there are no questions, I'll just keep moving forward. Just give me 1 second. I need to get just wetting my mouth for. All right. Let's see if there are anything. Nothing in the YouTube stream. Nothing from the. Okay. Alrighty then. Okay, so let's go back to this. Let's remind ourselves how the scan stream works. In order for me to do this, I'm going to probably have to create a quick server inside Common Lisp so that we can run experiments. Um, Give me a second. Uh, let's do another. Um, let's call this basic server.lisp. Here, we'll go ahead and do a quick load usocket, and I'm going to probably run this in a different image than my current image. So let me just go ahead and reach out to uh, um, start a new one. No, okay, so this is just going to be two different SBCL images. Okay, load up usocket. Okay, let's create our package, basic server. No, no, no. I did it again. US socket for socket chem, and let's go ahead and do that. And we're going to have to obviously listen in on our socket and then create a handler for this. So I'm just going to call this server main, and handles all the incoming connections. Now, this is not going to be a multi-threaded server. I should write this in a multi-threaded fashion, but I, it's going to just handle one connection at a time. So it's going to be a completely blocking, and then we can multi-thread it later on. Um, okay, okay. And here, if I remember, I have to do usocket. Wait. Oh, my apologies. I have to do this in package basic server. Okay. Okay. So for folks who are noticing that I'm switching the packages inside my REPL, this is just so that for those of you who are on the live stream, you could tell the differences between the different REPLs. You don't necessarily need to do this when you're actually doing real-time development, but it does become nice and convenient, especially if you're working through two different programs, to know which package you're kind of developing inside of a particular Lisp REPL. This is just, my own like little 2 cents on how to develop a little bit. Um, but those of you who have other, nice little packages like ideas like that, let me know, because I would love to know. Add waiter. Okay. I did not even know what that is. I'm kind of curious what that is at some point. So this is, I think it's with server socket. Yeah, there it is. Or with socket listener. Hold on. What is the difference between these two again? Which one do I need? I think I need socket listener actually. Sock, and I have to provide the listen args. Yeah. 1 second. This is going to be Let me just double check here what this actually maps to. With server socket. Oh, perfect. So this already does that for me. Okay. And so server socket. Okay. So this one is going to be listen arguments. Just got to remind myself what the listen arguments are, because documentation US socket listen function. Okay, so these aren't keyword arguments. Okay. And let's just say, for the sake of example, we're listening on 5,000. Okay, this should be okay. Let's make sure that we can expand. Boom. Okay, so this is okay with socket listener. So now we need to do an accept on a connection. Let con be US socket accept sock, and then we need to provide an element type. So let's just grab this as integers, because we're going to be actually sending integers across the wire. Okay. And all I'm going to do is I'm going to loop to 1,000. Okay, just like all the other examples. So loop for I from 0 up to 1,000. Okay, and do socket need to actually write to the socket, but I'm trying to. We need to write to the socket, but I'm trying to remember if right. So I can use format for this. Okay, got it. So format. Now, for those of you who are just coming in and don't know usocket when it accepts and creates a connection, it is not creating an actual stream socket. So it's not creating an actual Lisp stream. What I mean is it's giving you a socket object that represents a new connection, but you need to still create a stream object on top of that connection in order to actually be able to use the stream libraries like format and so forth that takes in a stream, um, and be able to write into it. So that's kind of what we're doing here. But I forgot I have to add one more thing. So this is going to end up having to be a prog n. So the first thing we need to do is first on format, then take you socket stream the connection, and then now we could actually write to it. So what we'll do is we'll write an integer. Um, I'm wondering if I could just use a and will it convert it to an integer? It ought to, but we will see. Let's see. Okay, and then here we go. And now we need to force it to go down the pipe. So we need to call usocket force, I think. What is it? Socket. Oh, got it. There is a function called force output that we can use. And for folks who've never seen that is here. Um, force output is basically a common Lisp utility that allows us to um, write out um, write out directly. It essentially forces it, as the name suggests, to execute the actual dumping of whatever stuff that's in a buffer into the actual stream. So it's so what we have to do is we need to do this socket stream. That's it. So now our server should be done. And then naturally we need to still close the connection. Um, so this entire section here of the loop has to be in a what's called an unwind protect. Um, so we need to an unwind protect is kind of like a it has a implicit finally essentially for folks coming from other languages. It has a finally so that it always executes that before um, exiting the form. So I'm going to go ahead and create the unwind protect. Grab this. Okay. And here, I'm just going to go and say us socket close on the connection. That's it. Okay. And then ideally with this socket listener, this should also have an unwind protect, but can't tell. Does not. So what we're gonna probably have to do is but let's see if okay with connected socket. yes, it does create an unwind protect. So you can see just how much. One of the nice things about Common Lisp is you could write these really nice convenient wrappers, and it doesn't like it uses the same parsing to actually make sure that all that boilerplate that you see here with the unwind protect and all that stuff is there for at least the top level socket that you're leveraging. Okay, so let's go ahead and do that. Um, let's go down here and let's go ahead and start our server. Server main. Okay, so now let's see how we can hook this up into scan stream, shall we? Okay, so here we need to also use um, usocket for the client side stuff. So we're going to go ahead and load up usocket into our client image. Oops, damn it. That's not what I wanted to do. Dang it. Oh, 1 second. To abort. Okay. Let me see if I can hook this guy up by doing slide default Lisp. Um, no, not that. I'm trying to switch between different Lisps here. Just give me a second here. I'm trying to create the first. Oh, maybe sly mREPL. Let me see if that works. No, no, that's not it. Um, it is. Which one was it? It is. Let me see what happens here. Nope. Okay. Looks like we're gonna have to write our code and then save it and then uh, uh, do a reload directly into my buffer right now, and then I will take a look at understanding why I'm not able to switch between two Lisps at the same time. Slide navigation, unfortunately, I'm still not as expert as I ought to be. Let's see here. Okay, we loaded it. Let me see if I can somehow um, just 1 second here. This would be okay. really don't like this ability, but I should be able to actually switch. Um, no, that's starting a new. 1 second. This is. There is a question here. Switching. Ah, here we go. Let's see if this works. No, hold on. This is starting to bother me. Um, okay, I'll worry about that at some point. I'm going to do it the old-fashioned way. Okay, so the first thing we need to do is we're going to create another thing called, I'm just going to call it series client example, just to show how this would work with series, and then we could build our transducer example, the time remaining. Um, simple series client that computes from a network stream. Okay, so now what we'll do is we need to first, we're going to add one more thing here, which is I'm going to go ahead and restart this guy. See what happens. Okay, so now let's see what this does. Okay, and let's get this in. And before we do that, I'm going to go and add one more local nickname, usocket. Okay. Now in transducer examples. Okay. US with client socket. We're going to just say, I guess, con to make things easier. We're going to listen in on, we'll oh, that's right. We need to actually add the stream that we want to as well. Um, it's TRM. And let's do the socket connection. So we're gonna go on and 5000. Okay. And what we'll do is we need to also specify, just like before, the element type. Okay. And element type integer. Okay. And let's might be a bit ambitious here because I'm not entirely sure what's going to be sent across the wire with element type integer on the server side, but I'm hoping everything is going to work as designed. Usually I'm going to be debugging at some point, so fair warning for folks coming in on the stream. Um, okay, so we now have our integer stuff, but and our stream, but we don't necessarily want to use like US wait for input and stuff like this, right? So I was hoping that I could just do collect some s scan stream on the stream strm, and I should be able to just do a read line instead of a read. Um, so let's do read line instead of a read. This is taking in, if you notice, what I'm doing is I'm overriding the optional scan series reader from read to read line. Okay, so that grabs each one at a time. The reason why I'm using read line is because if you notice on the server side, I have after sending each integer, I actually use a tilde percent, which is essentially a slash n. That's a new line for each one. If I wanted to do this one at a time, I could certainly have removed that, and then we could just use read. But for the sake of example, I use that. I started the server. Let's go ahead and use readline and see what happens. Now, in a perfect world, this should do what we're expecting it to. It will create a scanner that'll keep reading in through on the inputs, and it will then what's it? It will then, instead of using, because usocket in a perfect world, in most examples they will have like a blocking call that you call wait for input. But I'm hoping that that's taken care of by using scanner directly. We will see what happens, um, and then go from there. Let me see if there's anything I missed. Oh, right, because I'm still using a thing, I have to create an unwind protect here, maybe. Let's see. Socket.close. Guess I could just do okay, so this is the generated code when we're using this with client socket macro. I'm just double checking if I need to write a unwind protect here on closing this. It doesn't look like I do. I mean, it doesn't, honestly, it doesn't really hurt if you end up adding this and saying CPWR unwind protect. Okay, and then the end of this call here, we do US socket close, not clons, close, con. Okay. And here we go. So let's go ahead and run this guy, and hopefully it will do what I expect it to, but we shall see. Series client example. And now we have unknown error. Here we go. The condition could not find any input routine for integer occurred with error no 0. Okay, so it's not liking the fact that I'm trying to use an integer as the element type because it can't do the serialization. Okay, fine. You want me to write one here, here. Okay. Let us double check one thing. Oh, we could just do this. Convert this into character. Character. Okay. Unfortunately, I'm gonna have to do this. Yoink. Because my default Lisp has changed, so I'm gonna have to do it this way. Oops. Oh, crap. Okay, 1 second. Gotta do this too. You start Lisp. Okay. Because it didn't kill the. Let us do. Now I understand why I have to do this. I'm adding one more unwind protect. So this way it always signals in the abort case, it will always end up closing the socket. So we can actually reuse. I forgot in abort, it does not do what it's expected to do. US socket close sock. Okay. So there we go. There we go. There we go. There we go. And run server main. Okay. We start our Lisp here too as well. And that's character now, and we're gonna have to make characters here too as well. So do this, do that, do that, do that. S. Okay. So now that it's character, we're gonna have to change the read slightly. Instead of read line, it's probably going to be a lambda that needs to return a parse integer if we want to collect some directly. So what we do is we do, I'm going to go ahead and put this on a new line because lambda stream, okay, parse integer from string. So the string is going to be read line stream. Okay, and let's go ahead and dump this here like so. Okay. Okay, what is the warning? Warning, tag, 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 in series collect some. Function called with 3 arguments wants exactly 1. Um, oh shoot. 1 second. Um, um, this guy. Um, okay, 1 second. It's this one. Okay. My apologies. I accidentally closed out a window that kind of is messing things up. Um, 1 second. We're gonna go through a small break here while I go and fix this. Talks amongst yourselves. Give me a second. Okay. Okay. And there we go. Okay, we are back. G, Shift G. Okay. Okay. And it's saying that I'm calling some functions with 3 arguments, but what function am I calling with 3 arguments is my question. Saying D series examples. I am. Oh, got it. Got it. Got it. Got it. Got it. Got it. The lambda is doing something incorrect. Fine. There's multiple ways of skinning a cat. Let me take this guy out. Let's do this here. Okay. Make sure that we're back in normal. But in order for me to collect the sums, these are characters. I'm going to have to probably run a map on this. CPR S map, I think it's called map function, or mapping is probably what I need. And oh no, not mapping. Map function is probably what I need. Type integer function parse integer. And we have our scanner. Done. Okay. Let's see what happens here. Clear REPL so I can actually make sure I should have done that first. Save. Compiled, loaded, no warnings. Good. All right. Let's see what happens when I call this. Boom. So this is our basic example of reading off from um, a stream. Obviously, there was a little things that in the series example that I needed to remind myself I can't. For example, I was doing too much with scan stream. The function scan stream behind the scenes is actually adding more information, so the lambda needed to take more arguments. So it forced me to write in a more functional manner. So this is kind of cleaner anyway. But you could see that it was pretty quick, pretty straightforward. We didn't have to do anything special for dealing with network streams at all. We can use all the existing Lisp functionality in the library to actually generate this code, and it will do a quick computation. The transducers approach, I'm assuming, is going to be very similar in kind, um, but we might have to do a little bit more work, mainly because, um, again, like I mentioned, I don't believe that there is an equivalent. I didn't see at least an equivalent to uh, the uh, the streaming kind of example inside the transducers library, at least not today. Um, Foskers, if there is one, let me know, and I will um, certainly demo it. But I'm going to try and write this from scratch just to see what the difference is with the time remaining. Obviously, folks watching, if you have questions, feel free to post in the chat while we're going through this. Naturally, it's going to be just a run of the mill as we're currently going through stuff um, to create this transducers example. So let's go ahead and do a defun. Let's call this transducers. Well, transduce client example. Okay. Um, it then let's go ahead and um, let's see. We're gonna have to do the same infrastructure that we had before with clients. Oh, what the hell? There we go. With client socket. Okay. Um, 1 second. This down. This down. Con stream 127.0.0 on 5000. Again, we're gonna have our element type is going to be character. Okay. And let's go here. We're going to do an unwind protect. Make sure our socket gets closed with con. Okay. And now what we'll do is um, we need to create the actual transduce piece. Now this consists of, if you recall, and I will put this in this upper left-hand corner, sorry, right-hand corner for our viewing pleasure. Um, it was transduces construction consists of essentially a t:/transduce, which consists of 3 different arguments: a transformation, a function that actually is going to be leveraging the well, not leveraging, it's going to end up being used to actually generate the final answer. So the transformation here is using cons to actually create a cons list, but we have other examples here that we end up leveraging um, other things. Hold on one second. Where is this? Ah, here. Like integers, and this is essentially going to be our reduction function, this f, and then we'd have to specify the source. So here in our transducer, what we're going to do is first let me go and obviously specify um, what we're planning on doing is, which is naturally we're just going to add, okay. Um, our This is our third argument, okay. Sorry, our second argument. Our first argument is going to be literally be a is what we see here. It's going to be a read line followed by a parse integer. Okay, so I'm hoping that I could just simply do t colon comp, meaning compose. Okay, go ahead and then compose essentially. Um, well, I don't know if this is going to work, but we will see. Um, uh, Let me see if there's a parse. No, there's no parse. I'm going to have to do, let me see if I could just do parse integer and a read line, like so. Um, and then we have our things, and then our, what we're going to end up having to do is, no, this is not going to read line at a time because it doesn't know that this is a a network socket. So we're going to have to probably write some custom functions to actually handle taking of each example from each packet. Um, okay, this is going to require us to actually dive into um, the transducer's code to see how we can construct something similar. Let me see if there is a t colon stream before we end up leaving. No, there isn't. We're going to have to write a t colon stream. Okay. Since there's only 10 minutes remaining here, we now know what at least we need to do. There's a couple things that we need to do, and next time we'll handle this. Um, Next time, what we need to do is I will demo writing um, a custom transducer data source for the purposes of being able to hook it into the infrastructure. And then we need to write a couple of functions to handle reading off the stream, okay, and parsing the integer out. And if we write this correctly, this can be extended to doing, excuse me, to doing deserialization, like demarshalling, and writing a full composition of taking, like, saying, an object and writing in a composable fashion a sliding window on whole objects. So this requires a little bit of more work, but I think it will end up becoming just as clean as the series example. But obviously, it's going to have to require some deep dive parsing the integer, and then we could go to extending it to writing um, for more complex example for writing, uh, analyzing objects. So that's all I have for today. Um, Folks watching, I appreciate you taking your time out of your Saturdays to watch this. Just two announcements. One is unfortunately um, I'll be unavailable next week to do the stream and study group. My apologies ahead of time. Uh, but I will reconvene more regularly after the second week of September. I will get I will provide some more examples. Again, I'm not forgetting for those of you who are itching to start PAIP, Paradigms of Artificial Intelligence Programming. I'm trying to get my bearings around how to kind of present some of the material, mainly because of the fact that a lot of things have changed since that book was published, particularly the notions of deep learning and stuff like that, and machine learning, transformers, architectures, and um, things related to that. I want to also cover that material too as well while we're going through these paradigms. And so there's going to be a lot of projects and a lot of coding examples and stuff like that with that book. So it's going to probably be an ongoing series for at least a few months. So uh, it just needs to require some planning to actually go do that. Those of you who are on the functional programming meetup, I will give you more updates. I encourage those who are on the live stream, please go to meetup.com and join the Atlanta Functional Programming Meetup just so that you can get up to date announcements from me. Um, Obviously, if you like the videos that you're watching and the material that you're seeing, please like and subscribe to this channel, the Atlanta Functional Programming channel, for not just more common Lisp study group YouTube videos, but I do occasionally present material in other languages too as well. Please look at our channel, like or subscribe. Thank you for joining.